Okay guys, this is dividing monomials. So you're doing this lesson the same day as the last video, which was powers of monomials. So today we're learning the quotient rule. So the last video I couldn't remember the other rule, but it was the product rule. So it just came to me. With the product rule, recall that when we had x to the power of a times x to the power of b, we added a and b. So if multiplying means that we add our exponents, dividing means that we're going to subtract our exponents. So that is the quotient rule. Quotient, remember, is division, but we'll actually be subtracting our exponents. So we're going to have x to the power of a minus b. Now let's look at why this works. Okay, so if I were to expand x to the fifth and x to the third, this is x times x times x times x times x, 1, 2, 3, 4, 5, all over x times x times x. Well, let's look at how many groupings of x over x we have. That's 1, 2, 3. Anything divided by itself is one whole. So that's 1 times 1 times 1 times x times x. So basically all we are left with is x times x. You could think of 1 times all of that, right? We have 1, 1, 1, which is just x squared. So instead of having to expand everything and see what divides out, we can just subtract the 5 and the 3, okay? So that is why the quotient rule, that's where it comes from, basically. It's why we subtract. In order to subtract the exponents, though, they have to have the same base. They have to have the same variable. So for example, I can't subtract like the 6 and the 3 here because one's an A and one's a B. So I need to subtract. You can think of it kind of as like terms again. They're not like terms because remember, like terms have to have the same exponent, but you have to think, okay, in order to divide them, they have to have the same variable. Okay, so I see here, I have a to the power of 6 over a squared, so that's 6 minus 2. So I'm left with a to the fourth, b to the fourth, divided by b to the third. 4 minus 3 is 1. You can write your 1 in there or not, right? Because remember, it's still there whether we write it or not. It's an invisible 1. Alrighty. Okay, so same thing here, and I like to draw my invisible ones in because I think it just helps us to see it visually. So here I have x's, y's, and z's. So I'm going to subtract my exponents for x's, y's, and z's. So for x, 20 over 5 is 15. So I have x to the 15th. Y to the 9th, y to the 9th. I have a lot of students who just write y. So let's talk about this concept for a second because I don't think it's come up yet. I'm not sure, but I don't think it has. So y to the 9th over y to the 9th. First of all, as I mentioned recently on the other problem, anything divided by itself is one whole. It's not y to the 1, it's one whole. But if we want to use the quotient rule on this, we can. 9 minus 9 is 0. So this isn't y to the power of 1, this is y to the power of 0. Now, at this point, I would ask my class, what's anything to the power of 0? And the majority of students would say 0, right? A lot of students would say 0, they would shout that out. No. Anything to the power of 0 is actually one whole, okay? And there's a whole explanation of this. Every time someone asks me why, I always have to look up a YouTube video because I forget why it works. But so if you really want to know, there are videos on this, why anything to the power of 0 is 1. It's not hard to understand. I just always have to look it up. So yeah. So whenever you see anything divided by itself, we're not left with y, we're left with y to the power of 0 or whatever variable to the power of 0, which is one whole, okay? So I just like to think of it as like, it doesn't disappear, because when I think disappear, I think 0, because some students will be like, oh, it disappears, and like cross it out. Like, yes, it kind of disappears, but ultimately it becomes one whole. So that's a long explanation for this answer is just x to the 15th and z. to the power of 1. So the y is kind of gone. It turns into one whole. There it is, one whole in the front, which is also invisible. Okay, now, what if we have coefficients in the front? Well, if you remember with the product rule, we multiplied our coefficients like normal, and we added our exponents. So here with the quotient rule, we're going to divide our coefficients like normal and subtract our exponents. So 6 over 2 is 3. And 4 minus 3 is 1. So that's just 3x. Okay. Here, same thing. I'm going to divide like normal. Negative 36 over 4 should give me negative 9. C squared over c squared is 1 whole. So negative 9 times 1 whole is just negative 9. And 5 minus 3 is 2. Okay. Here, I want you guys to notice when you have a smaller number on top, we are going to simplify, okay? So this is going to be simplified, 36 over 54. When I saw 36 and 54, you know, if you want to write it off to the side, if they're bigger numbers, you can and simplify it that way. I immediately thought of 9, but then I learned that that number was not big enough because I could still keep going, which is fine. I know you guys don't have calculators right now, so you're going to have to, like, it's going to be a process. So I found 4 over 6, and then I said, okay, well, 2 still goes into those. So I'm going to divide top and bottom by 2, and I'm going to get 2/3. So really 18 actually goes into 36 and 54. That was the greatest common factor there. Okay. So this is going to simplify to 2/3. If it simplifies to a fraction, that's fine. Okay. And then we're going to subtract our exponents like normal. So I have m to the 6th, n to the 3rd. All right. Now we have some mixed practice. All right. So this is going to bring in the power rule, the product rule, combining like terms. This is going to bring in everything. All right, I'm not going to do every single one of these. Maybe I'll do 3, okay? But you can see how all of these different rules regarding exponents are all kind of building on each other at this point. Okay, I would say which one do you guys want me to do, but you're not here. So let's go for, let's take a look at, I don't know. Let's do 8, I guess. So 8 here, this was the last lesson, was the power rule, right? I can see this 4 is being distributed to everything, and this 2 is being distributed to everything. So if I rewrote this, 2 to the 4th, that's 2 times 2 times 2 times 2 is going to be 16. C to the 1, first power times 4, c to the 4th, and d to the 16th, all over 2 squared is 4, c to the 4th, d to the 6th. And from here we can simplify, right? So now that we distributed those powers, this is what we just learned today. 16 divided by 4 is 4. C to the 4th over c to the 4th is 1 whole. And then d, 16 minus 6 is going to be 10. Oh, why isn't my pen working? There we go. Okay, number 9. I did want to point out on number 9, we see this whole thing is being raised to the 3rd power. So I kind of touched on this in the last video. This is saying that the numerator and the denominator, everything basically is being raised to the 3rd power. I like to rewrite it like this, basically putting the 3rd power on the top and the bottom. Because I just think it's, you know, easier to see. We're not forgetting to distribute the power of 3 to the bottom. Okay, so from here, 2 to the 3rd is going to be 8, m to the 12th, n to the 6th. The bottom, 4 times 4 is 16, times 4 is 64. M to the 6th, n to the 3rd. Let me just double check my exponents. Did that kind of fast. Okay. Now I can see I have 8 over 64, a common mistake. I see it in honors classes and not honors classes, is students just put 8. Okay, this is not 8. This is not 64 divided by 8. This is 8 divided by 64. So instead of 8, this is actually going to be 1/8, right? I understand that you're thinking about the 8s, dividing them, that's good, but we have to remember the smaller numbers on top. This needs to stay a fraction. So 8 divided by 8 is 1, 64 divided by 8 is 8, okay? Then from here, we can subtract our exponents. So I have m to the 6th, n to the 3rd. Alrighty. Okay, let's do one of these at the bottom. They look fairly similar. I would say 12 is a little more complex because we have the powers and the dividing and the subtracting. So 12 can either be a pretty answer or an ugly answer. It all depends on if when we do all of this, if we get a like term here. If we get m squared n to the 5th after we compute all of this, then we can actually subtract. If they're not like terms, we have to leave them separate. Okay, so let's find out. I actually don't know, so I'm interested. I'm gonna distribute both of these 3's here. So I have 2 to the 3rd and m squared to the 3rd. Then I have 3 to the 3rd and n 4th to the 3rd. Wow. So 2 to the 3rd, that's 2 times 2 times 2 is 8. M to the 6th, right? So I'm following PEMDAS. I have exponents first. Now 3 to the 3rd, that's 3 times 3 times 3 is 27. N to the 12th. I think I might have written that too big. Well, it's okay. I have lots of space. You guys are gonna have to write a little smaller. And then on the bottom here, we have 9 m to the 4th, n to the 7th. All of this is subtracting that. Okay, now next thing, I did exponents. I need to multiply. So right off the bat, up here, I saw these were going to be multiplied after I did the exponents, right? So this is being multiplied. I'm going to cheat and use my calculator. No, I'm not actually cheating, okay? 8 times 27 is 216. So now I have 216 m to the 6th, n to the 12th. I can't add the 6 and the 12 there because they're not the same base, right? They're not the same variable. Okay, and that's all over 9 m to the 4th, n to the 7th. So let's see if we end up with like terms or not. It does look like we're going to end up with like terms once I subtract my exponents. So 216 divided by 9 gives me 24. 6 minus 4 is 2. 12 minus 7 is 5. So yes, we have like terms. And I can subtract 24 and 18, not using a calculator for that one. It should give us 6. Let me double check that. Yep. M squared n to the 5th. Okay, so this one had a lot in there. We had to do the power rule. We did not use the product rule because we did not have common variables, right? We used the quotient rule and we combined like terms. So that was a good one. Okay, I am just about at my time for the max time on my video here. You guys are doing all for the homework and the sub will have an answer key. Alrighty, bye.